Okay, welcome back. The next fitting we're going to look at in our series here is our OgeeOffset. So it's a duct fitting that's going to change the elevation of a duct run, maybe get around an obstacle or something like that. Now again, we're starting off with a shop drawing, 4x6 duct with a 3-inch offset. Now, again, our 4 is what's visual here in the view. We want that one. This 6 is our depth. Okay, and then it's offsetting a total of 3 inches here. Okay, so the bottom on the left-hand side is 3 inches taller than the bottom on the right-hand side. We also need a length that we haven't been given, and normally you may be given a length in it, and you may be given an indication as minimum. So the minimum length, because an OgeeOffset can't transition too much of an offset in a short length. It starts turning into too much like this. Okay, and air's not going to flow down that very well. Okay, so what we can take is our minimum as what we refer to as owl. And what owl tells us is the offset plus the width equals the length. So in our case, 3 plus 4 equals 7. So our minimum length here is 7 inches. Okay, so sometimes we've got to fill in the blanks of our fittings based off of regular code for those fittings. Okay, so now we have all the information we need to start our blank sizes. Okay, and this one, same as the last, we're going to have a cheek. And our cheek size, again, we want to have the vertical and horizontal dimensions, or the X, Y dimensions, to be able to, how big of a piece does it take to fit this cheek on there. Okay, so we're looking at something around here that encompasses that whole part. Okay, so if we look vertically, we know we're 4 here and then 3 here. So we have a vertical of 7 inches. Our length is 7. It's given, or we found it at 7. Okay, so our cheek is 7 by 7 in this case. The other 2 parts that we have are called the wrappers. And the wrappers are like the heel and throat. They're the sides that connect the 2 cheeks together. Okay, and on the wrappers, we have a very specific, it's a formula you'll probably only ever see in sheet metal. I don't know if you'll see it anywhere else. And what that formula is 4 times the square root of the offset squared plus the length squared minus the length divided by 3. Okay, so this one again, with all math, we have a certain order of operations we have to follow. So let's throw in a couple of brackets just to kind of make sense of things. The square root of the offset squared plus length squared, this needs to be done first. Okay, so we go offset squared plus length squared equals, and then take the root of that. So let's put a set of brackets right here. And this goes back to bed mass, brackets, exponents, division, multiplication, addition, subtraction. So now we've got brackets here, we know we do that first. If we looked at bed mass again, we would do any multiplication before subtraction, so we multiply by 4 next. Then we can go and minus the 3, and even though this is a minus and we have a division, the division line is over the whole top of the equation. So that means we have to complete everything up here before we do the division there. Okay, so we minus the length off, then we divide that answer by the 3. Okay, so we'll look at punching that whole thing through our calculator. Once we have that, then we find our blank sizes for the wrappers. Okay? And we have our offset here is 3. We have our length is 7. Okay, so let's punch those through. Let's get our blank size for the wrapper. Okay, we're back and we're going to look at we're continuing with the OgeeOffset, but we're going to specifically look at the wrapper formula and calculations for the wrapper. So we saw we started with our shop drawing of our OgeeOffset. We had our length and offset. This is just a tiny one, but nonetheless. Same idea, our number given for the opening was this dimension first, which we saw in our shop drawing view, and then the depth is our second. And in this case, the depth becomes the width of our wrapper. And this is the wrapper here. That's the part that joins the two cheeks that goes along the double curve here, or the OG curve. OG just means it's a reverse curve, so it's the double. This is an OG curve right here. Okay, so this is the wrapper part. And being that we're on two curves like that, we don't know angles or radius points or anything like that to mathematically calculate it. And we have this formula here that will allow us to calculate the length of that wrapper. 4 times the square root of the offset squared plus the length squared minus the length divided by 3. Okay, and we're going to work that one through. So let's get started on that. And the first thing I like to do, I mean, you could run this through. We said we got to keep bed mass in mind. So we could put a whole bunch of brackets in here to make sure, and we'd need maybe 3 or 4 sets altogether. But I'm going to show you the way I like to do it to break it down a little bit. So first off, let's fill in our numbers. And let me just sketch a quick shop drawing here. We were 4 by 6 with a 3-inch offset. We went with a minimum length in our case, which was 7 inches. Okay, so that's our starting point there. So let's fill in some of the numbers that we know. The offset is 3. The length is 7. That goes there and here. So now everything's numbers, at least. There's no more variables in it or letters. So let's punch that through. So we got 3 squared is 9. Seven squared is 49. So we continually just break it down a little bit further. 9 plus 49 is going to be 58. We can see there now, 4 times the square root of 58 minus 7 divided by 3. And we know this whole top gets divided by 3 because this line extends all the way across. Okay? And we know that it's only the square root of 58 because the square root sign doesn't go beyond the subtraction sign here. So from the rest of it, I'm going to need a calculator. So I can come in and square root of 58 equals, and this one I'm just going to jot it down below it, 7.616. Now 3 decimal places is lots. So now I have this number. This one is gone now. Okay, and same with the square root. We've dealt with that. Times 4 equals. So once I take this number and multiply it by 4 now, I get 30.463. Okay? So now I've done all this. And it's 30.463 minus 7 divided by 3. So let's minus 7. And I'm going to rewrite everything over here so we can see it again. And I got 23.1 463 divided by 3. And that gives me a total of 7.821. Okay, now the 0.821 is no good to us in decimal form. So let me just scrub this one out here. And what we get there in the end is 7 13/16. That's the length of the part that goes along that curve. So if we took like a piece of string and laid it along the curve and marked each end and then straightened it, it would measure 7 13/16. So that's our cut size, that's our stretch out or length size of the length. And then we know that the second dimension comes from the 6. So this becomes our blank size. 7 13 by 6. We know the 17 or the 7 is 7 13/16 is just a little bit longer than the given length at 7. And what that tells us is that we're on the right track, because a curved line is going to be a little bit longer than a straight one. And because it's on a slope, we know that it's going to extend a little bit more. Okay, so we have our blank. That's our wrapper size. Okay, and then we had this is the wrapper. And we had our cheek size earlier that we calculated out to 7 by 7. Okay, we're back to continue on with the OG offsets. Now, we've done all our blank size calculations. We're ready to start our layout. So I've drawn up my blank here. I got my my cheek anyways. Like we said, there's no real layout or any marks you even need on the wrapper, so we won't draw those out. I got my 7 by 7 for my cheek size. Now, first thing I'm going to do is mark the openings on each side. And if we go back to our shop drawing, we're looking at a fitting like this. We said the length overall is 7 inches, and it's a 4 by 6 with a 3-inch offset. Okay, so that again is our typical shop drawing. So now I'm gonna replicate those dimensions onto my blank size here. So my direction of airflow is kind of going this way. And I like to do it even with the OG with the drop in it to show where my openings are. So I know the opening is up here on the left, and then it drops down on this side here. Okay, so let's go ahead and mark out our 4 inches. On that side, and I have 4 inches on this side. Along with that, I want to mark my center point of the opening. So I'm going to put a mark in right here at the center of the opening, and I'll just put a center line mark. CL. The CL just means center line. Okay, now I'm going to remove my airflow line because I now have an idea of where it's going, and the next line I draw in is going to indicate that as well. So grab my straight edge. Now what I want to do is connect center line to center line down this way here. Okay, so maybe I'll even move this one outside as well. So we do everything. It'll be nice and clear on the inside. Okay, so let's connect center points. Okay, so got my line drawn in there. Our next step is to take this center line now and divide it into 4 equal parts. And the way I want to do that is back to geometric construction. We're going to use our ruler on a diagonal to accommodate that. Now, We can use that technique. Usually we use it in 12s, but we can use it in any number. And 4 is what we want in this case. So if we start thinking of a number that is easily divisible into 4, 6, 8 are all different options. 12 is an option. And we're close to 8. We're slightly short of it. So we always need to increase it a bit because our ruler is going to get longer as it goes on a diagonal. So 8 or 10 or 12, any of those are going to be options. So I'm going to use 8. And it doesn't need to be along my center line again. It can be anywhere along here as long as I'm hitting 0 at one vertical. And my length that I've chosen, in my case 8 inches, on the other vertical line. So here we go. And in this case I mark every 2 inches. And from there I get my 4 equal divisions, square those up to our center line, and we're good to go there. Okay, now if we put some numbers on here, and I'm just going to number this 0.1, 0.2, and 0.3. I now want to create a perpendicular line from point 1 and 3, so the outside marks. And I'm going to shoot that perpendicular into the offset. So here's my offset down here. And over here, it's opposite. It's on the top here. So I know that the offset is here and here. Okay, so that's where I'm going to direct my perpendicular line. And I want it to come and cross this vertical here. Okay, now it may end up in our blank size or it may not. It could come all the way down and maybe hit down here somewhere. In that case, I'll just have to extend this line until they cross. Okay, and again, I'm going to go back to geometric construction to create a perpendicular line at a point on a line. So I can take my dividers, and again, you can go back in the book and review these techniques. Swing an arc there, swing an arc there. Swing an arc there, and there. And this one will come in here and here. And there. And we draw those through. We use the 2 points to connect that through. Now, I didn't mention that we do have 2 different ways to draw this OG out. We have geometric construction, which we're doing here, or we have mathematics. And either are acceptable in any case. Geometric construction obviously takes more work to it, more drawing. So anytime we have more drawing, we're going to lose accuracy and things like that. You can already see on mine, it's not exact. This one almost hits right in the corner. It's very close to it. This one's about maybe a 1/4 inch away. So I've got some inaccuracies, I know that. I'm sure it'll still work, right? But the mathematical way would be much more accurate because there's less drawing. Anything we do is going to cause inaccuracies. So we'll go over the math way once we finish this one up. Okay, so now if we just go back a little bit, we drew our blank out, 7 by 7. We drew our opening on both ends. We drew center of the opening at both ends and drew that line in. Divided it into 4 equal spaces. Labeled it 1 to 3. And points 1 and 3 got perpendiculars, and we wanted to know where it crosses our verticals on the outside. From this point, we're almost done. We're just going to take our dividers now, and where this cross where this crosses here, becomes our radius point. And that's where all the arcs are going to be swung from. Okay, so once I'm set to that, I'm going to pin my compass on that location. I'm going to swing an arc from here, which will achieve this arc. And from the same radius point, I'm going to stretch out to the very outside and swing an arc there, producing this arc. Okay, and then from the opposite side, it's the same thing, inside and outside of those arcs. One line we can throw in as well before we swing our arcs, and this just keeps things neat, is if I take my ruler and draw a line, and in your case this would be a really light construction line, but if I draw a radius point to radius point, that's the point where these arcs transition. So we have an inside arc here, and then at some point there it turns to an outside arc. And where they transition is exactly in this line, the connection of the two radius points. Okay, so that one just adds to the neatness of your drawing. It doesn't need to be there, but neatness. Okay, so here we go from my radius point. I'm going to open my dividers and set to the small arc. There we go. And I swing that one. And I stop right at that line there. Seeing how it's the same, I'm just going to flip over to this side and swing this one. Then from the same radius point, remember, we'll open all the way up to the outside. Now I always like to do a bit of a check here first. Before I swing that arc, I can bring it over, and I want it to match onto this arc here. I want that to match perfectly. Now I can see mine's a little out, and again, I knew a little bit off on my accuracies. We go from there. And there we go. So a lot of lines there for one, right? It's a little bit hard to see our true arcs, but you can see the red here is my cut for my cheek, for my OG curve. This one, this is where I missed a little bit, is through here. Okay. OG offset by geometric construction. Okay, we're back again, and I've cleared off the board. I've gone back to the starting points for the OG layout, for the cheek layout. 7x7 blank. Marked my opening and center. Marked my opening and center on both sides. Drew my center line down. So same up to this point as our last geometric construction one. With this one, the mathematical ways, what we're going to do is we have to use again a sheet metal specific formula that gives us the distance of that radius point that we found last time, but we found it using the geometric construction. Offset squared plus length squared divided by 4 times the offset. Now that the answer to this will give us a distance that we measure from center, again towards the offset. Remember, our perpendicular came up this way. So we're just going to measure a linear line now. Okay. So from our shop drawing, let's fill in some of the blanks here and calculate this out. So our offset is 3. Our length is 7. 4 doesn't change, times the offset. So 4 times 3. This one, 3 squared is 9, plus 49, divided by 12, 4 times 3. So what that turns into is 58 divided by 12. So let's punch that in. And what I get is 4.8, 3 repeating. Take off the 4 times 16, 13 sixteenths. 4 and 13 sixteenths of an inch is going to be our radius point. So again, that one from center, keep in mind, we're going to measure it from the center location down into the offset. So I take my ruler and there we go. So just like I did before, I've created my radius point. I've just done it in a much more efficient, effective way. You're going to have higher degree of accuracy, and it is truly a lot quicker. The other benefit to it is that I don't have as messy of a drawing. I don't have all those lines all over the place. I'll still draw in my line from radius point to radius point to give me that transition point. And then let's grab our compass. Again, we'll set from this one, swing down, come over here, swing down, and then all the way to the outside. Give it a checkpoint. That one's much closer than it was before. There we go. OgeeOffset by math. Same results. The cheek would be identical. It's just how we find the radius points is different. We're using the mathematical formula compared to geometric construction.